topic is open sourcing the cloud, will be presented by Alan Pickens from Rackspace. Thank you. Okay, thank you.
Thanks. Hello, everybody. I hope you're all well and not too tired at the end of the day on a Saturday. My name is Alan Perkins. I'm the Chief Technology Officer for Asia Pacific at Rackspace. I've been with Rackspace for about 9 months. Prior to that, I was the Chief Information Officer for a company called Altium Limited, which wrote software for electronic engineers. So that software was used to design all sorts of electronic products, very high-tech company. And for example, Jet Propulsion Labs, part of NASA, used that software to design all of the electronics for the rover, the Curiosity rover running around Mars. And NASA used that software for its spacesuits, and it's used by many, many different companies. So I was at Altium, I was one of the first CIOs in the world to take a global company to the cloud, pretty much in its entirety. And so I've joined Rackspace to talk about some of the benefits of cloud, and I thought, what a great opportunity to talk at a conference on open source, to talk about open sourcing the cloud. Now, cloud computing is an interesting thing. It's one of these things where we seem to make this mistake as humans again and again and again, where we get some new technology and we focus on the technology and forget about why the technology is interesting and what it does for us. And cloud computing is one of these things where we focus on, you know, is it cloud or isn't it cloud? Is it public? Is it private? Is it software as a service or platform as a service or infrastructure as a service? We focus on, is it, you know, what will this do for me? But we fail to see how it will revolutionize things for us, what changes it will make for us. And if you go back to the very beginnings of some of the earliest examples of what is effectively cloud technologies, the earliest example that if you look at Nicholas Carr's Big Switch, he talked about utility power in the 19th century industrialists' factories. These people had steam engines, 150 years ago, that were generating their electricity in the factories. And all of a sudden, somebody comes along and says to them, tell you what, I'm going to give you a new way of generating power. And this power is going to come from outside. You don't have to worry about where it comes from. All you have to worry about is if you plug into the wall, you will get electricity. No more steam engines. Oh, and by the way, if you don't use it, you don't pay for it. Now, I bet you that those industrialists thought, wow, this means I'm going to be able to turn my lathes more reliably, I'm going to be able to turn my lathes more cheaply, and I'm going to have a cleaner, safer, and quieter factory. Today's industrialists are thinking, wow, this cloud computing, this gives me cheaper, more reliable apps, and it gives me, greener IT. But I bet those 19th century industrialists didn't think initially, hey, this gives me lighting, and what does that do for my business? All they thought about was how they could use this in the same way they were already using it. Today's industrialists, which is us, I challenge everybody to think, what does cloud computing do for us that we couldn't do before? How does it change our business? Don't worry too much about CapEx versus OpEx and all of those sort of things. Cloud can change fundamentally the way we do things if we allow it to. So cloud, we get into this concept that cloud is about, public and private and so forth. Rackspace basically says that cloud is about being able to focus on your business without having to worry about where your IT comes from. Now, whether that's public cloud, whether it's private cloud, whether it's bare metal, it doesn't actually matter. What matters is, can I focus on my business? Now, when a fishing business starts out, the business owner has to make a decision. How big a boat do I buy? How big a net? Do I take a big risk and invest a lot of money in a big boat and go after a 20-ton school of fish? Or do I go after small schools of fish and not take such a risk? Now, if you decide to go after a small schools of fish and you come across a 20-tonne school of fish, what do? You have to say, well, you know what? Doesn't matter, I missed out because I wasn't prepared to take the risk. But if you buy the big boat and you go to sea and you don't come across the 20-tonne school of fish, well, then you're pretty screwed, aren't you? You've basically invested all this money and you can't get the fish. With cloud, you can go to sea in any kind of boat. You come across a 20-tonne school of fish, you just grow your boat, or you replicate it while you're at sea. So that's the kind of thinking that you need to be, thinking about with cloud. Not worrying about how, it's like with the industrialists with the electricity. Don't worry about how the power is generated. What best works for you? Now, I've talked about the utility, power and so forth. Cloud is like this. It allows you to have multi-tenanted access to different computers and different systems and storage and so forth. But if it's done properly, it also should allow you to seamlessly interconnect your private facilities with your public facilities. If you have to have some data that is very sensitive, you want to make sure that stays on your premises. You might want to make sure it stays on dedicated hardware. You might want to commit to a baseline of infrastructure that you invest and you say, I know that normally my requirements are, we'll say X. And I'm going to commit to X because I'm going to get a better deal if I commit to X. It's like when if you're going to have a car, right? You buy a car for your daily drive. You don't go and use a rent-a-car company because that's a very expensive way to get your daily drive. But occasionally when you get family visiting you, you might go and rent a car, or if you go to another city, you might go and rent a car because it's cheaper to rent a car than to freight your own car to that destination or to buy a car for a few weeks. So cloud computing, when done properly, is like this. It enables you to have this freedom to explore things in different ways. So it enables you to do many things. It enables you to get new hardware resources in a matter of minutes through a programming call, just a quick API call, and you've got new resources. It enables you to experiment and fail fast. I have one example where I was trying to experiment myself with a new database invention that I had made, and I wanted to see whether or not this invention would scale. Now, I won't bore you with the big details, except I needed to have 11 computers to do a test, and it involved testing 1,000 concurrent users. I needed a database server and 10 client machines to represent 100 users each. Now, to do this in a traditional way, I would need to go and buy 11 computers, and that's going to cost me, I don't know what, 15,000 US dollars, and it's going to take me maybe 2 or 3 weeks to set up. Now, I've got to be really, really confident in my design before I go and invest in that, aren't I? I mean, if I'm not confident, I'm not going to do the test. But with cloud computing, I could run this test, set it all up in a matter of 30 minutes or so, run the test for 3 hours, shut it all down again for a total cost of less than $5. Now, that's a game changer. That's the kind of thing I'm talking about that really does enable you to think differently, to think outside the box. So it fosters a paradigm of experimentation. It fosters people going and exploring new ways to collaborate. And with things like social media, the whole notion of the publisher-subscriber models that we can now build all comes about because of cloud computing. It also enables small businesses to compete with very large businesses on the world stage. You simply can't do these things without it. So one of my favourite quotes, the cloud provides the freedom to be remarkable. It provides businesses with the opportunity to focus on what it is that they do that is remarkable without having to think about their IT infrastructure to get there. And that brings me to talk about OpenStack. Now, OpenStack was founded by Rackspace and NASA working together. And basically, Rackspace, about 4 years ago, was saying, if all of these companies like Rackspace and all of its competitors keep going down the path we're going down, we're going to have a very, very poor situation for the world where there's all sorts of competing technologies for cloud. We're going to have some people providing one way of doing things, other people providing another way of doing things. We'll have incompatible APIs. We'll have clients who are locked in to one particular thing. Now, people here are obviously passionate about open source, so I don't need to explain to you the benefits of, avoiding vendor lock-in and avoiding, royalties that tie you into a company and its financial engine. So Rackspace said, I wonder who we could go out there and convince to join with us and build a cloud operating system that was open sourced. The idea being that if we can get many, many people to work together, then this will be very successful. How was Rackspace going to compete? Rackspace was going to compete because of its fanatical support. Rackspace provides, quite simply, the best support in the world. I didn't kind of believe this until I joined the company. I used to be a client of Rackspace. Yes, we got terrific support as a client, but what I learned in joining the company and going through its induction processes is that this company absolutely lives and breathes this fanatical support concept. And that's how Rackspace felt it would compete with all the people it was going to bring in. So it got together with NASA and it open sourced its source code. And so open source was born. It's a platform to enable you to build private and public clouds, and it was all completely open sourced by Rackspace and NASA into a separate foundation. And that foundation now runs it. I'll talk a little bit about the governance later on. But right now, I'll just say this. Rackspace, as one of the key founders of this, tested its ownership of this when it presented to the foundation 4,500 hours of work that Rackspace had put into this new technology for OpenStack, gave it to the foundation, and the foundation said, no, we don't want to do it that way. So Rackspace had to throw away all of their work because the foundation had decided to go in a different direction. That's the proof that it truly is open sourced and no longer belongs to the founders. That's a very powerful thing. So this is a little bit out of date, this slide now, but the idea is what I'm trying to show here is this is from a site called stackalytics.com. Now, Stackalytics shows you a whole lot of information about the OpenStack, how many people are working on it, and you'll see that in the top section here, you've got Nova, which is the compute instances, and that initially was quite in 2011, very high work. Now the work has sort of stabilized because it's a mature product. Swift, which is the storage, that again, more at the beginning, less at the end, is stabilized. And then you see Horizon, which is the dashboard, and Keystone, which is identity services, and then Neutron, which is the software-defined networking. All these things have come later and so forth over time. Now, OpenStack's releases are named after the various different places where the summit is going to be held. They have a summit every 6 months. And the summit is where they decide the release for the next OpenStack release, and it's 6 months apart. There were 200 contributors to Essex, which was the fifth release. They're named alphabetically. So the first one was called Austin, the second one was called Bear, B-E-X-A-R. Third one was Cactus, Diablo, XX, Folsom, Grizzly, Havana. And Havana is just been released this week. And the next one is called Icehouse, which, because it's being held in Hong Kong, they had to find something in Hong Kong that it starts with I, which is really difficult because there's no words that start with I. So they found a street in Hong Kong that's called Icehouse Street, and they've named it Icehouse after that. And there are 910 contributors, so that's sort of up here for the Havana release. So the growth of this every 6 months is astounding. And if you look at the number of people who attend each of the summits, the first summit, when they first got together to decide how this was going to be done, there were 50 people in the room. The next summit, there were 100. The next summit, around 175, then 350, then 750, then 1,500, then almost 3,000. These are all 6 months apart. It's amazing. And then the next one, which is being held here in early November in Hong Kong, first time ever out of America, and they're expecting to have between 4,000 and 5,000 people at the summit. So needless to say, Rackspace is very proud of starting this. Rackspace was hoping that other companies would get involved, and now somewhere between 300 and 400 companies, perhaps more, have now got involved with OpenStack, and not just small companies. HP, IBM, Cisco, there are many, many companies who are very, very large. Red Hat and Canonical have both got involved with an OpenStack distribution. So here's the attendance at the various summits that I mentioned. One of the things that Rackspace is most proud of is in the early days, Rackspace was by far the biggest contributor. But our contributions have continued to increase. But as a percentage of the total contributions, Rackspace's contribution has gone down because many other companies are coming up. Companies like Red Hat and IBM and so are coming up and taking on more of the load, which is a really good, healthy sign that the project is going very well. It's now the fastest growing open source project in history. It's not as big as Linux yet, but it's the fastest growing project in history. And this is just a quick graph that shows a percentage of all job ads that mention OpenStack resources. And I just saw, I just had a quick look today, there are 11 job vacancies in Hong Kong for OpenStack knowledge right now as we speak. So it's something that's really taken off. I want to now just give you a couple of examples of some projects that I think are really cool that have been run on OpenStack. The first one is CERN. Now, CERN they invented the web. It says the internet here. It's not quite true. It's the World Wide Web. But 3.5 trillion electron volts are thrown in two directions around a 28-kilometre ring underground and smashed into each other. And this is where they discovered the Higgs boson. Now, they generated something like a petabyte of data per second, of which you simply can't store all of that data. They have 15,000 servers that analyse that data, process it, and then store 20 gigs or so per second. Now, Rackspace helped them build all of this, but it's all built on OpenStack. And Rackspace is very proud to be associated with this and is helping support their initiatives. And right now, they're in the process of going through a 12 to 18-month project to double the capacity of their things. And here's an interesting photograph. Now, this is part of the Hadron Collider, but what's particularly interesting in here is this is a person. So you can see how big this thing is, just massive. That's underground. It's just huge. And this is taken from 2008, the tape deck to store the data. Okay, the other project I wanted to mention to you was a project called Nectar, which is an Australian government initiative to build a cloud of servers and network and storage for scientists to do scientific research in Australia. So scientists can consume these resources for their various scientific projects, and they have 32,000 cores available to them set in 8 different nodes around the country. It's basically set up in universities like this one around Australia. And finally, on this side of OpenStack, I want to just talk about the governance. So OpenStack is run by an independent panel of board of directors consisting of 8 members from the platinum sponsors, 8 from the gold sponsors, and 8 from the silver sponsors, which means that the big boys don't get to dominate. So you've got small companies, medium-sized companies, and large companies all involved in driving the agenda of where OpenStack will go. You then have a technical committee, and the technical committee is independent of the board. The board decides where we're going to go. The technical committee decides how we're going to get there. And the two have no authority over each other, so that the technical committee is based upon a meritocracy. Anybody who has made a contribution to OpenStack is able to have a vote for who's going to be in that technical committee. So the process is that there are core reviewers, and those reviewers basically vote the code, and then you get a certain number of votes, a certain number of core reviewers and other people who vote the code up or down, and then it gets submitted to a Jenkins for deployment. There's also, at these summits, there's a series of people who get together in these summits, including the one coming at Hong Kong, where anybody who is, member can come along and make a contribution about what's going to happen in the next release. So we've just released Havana. In about less than a month, we're going to get together and discuss what's going to happen for Icehouse, which will be released in 6 months' time. And for those people who are code contributors who can't afford to get to the summits, who are like individuals and so forth, the foundation provides them with financial subsidies to get there. So now I'm going to talk a little bit about the technology. So we've got basically the 3 key building blocks are the compute, the networking, and the storage. And there's a number of other projects associated with OpenStack, but these are the foundational building blocks of OpenStack. And as I said at the very beginning, OpenStack can be built on a public cloud. Rackspace's public cloud is all built on OpenStack. It can be built on private cloud, and it can be built, you know, in a mixture of different ways. So talking about, first of all, the compute, which is called Nova. So this is basically your ability to fire up a computer instance in a matter of seconds or minutes, and depending upon how you've configured it, those compute instances will have different amounts of RAM. You'll be able to, you know, increase the size of the instance, reduce it, and so forth. Typical, you know, infrastructure as a service. Glance provides a means of storing images, compute images, so that you can, you know, have templates that you then fire up in different locations and so forth. Then you've got Swift, which is the object storage. So Swift basically enables you to store different files. And these files work on a ring architecture where there's a number of different rings based upon address and authorization and identification. And the files are stored in 3 separate locations every single time you store a file. So it's designed to be very robust to make sure that your files are not lost. Then there's Cinder, which is block storage, which basically means you can attach a block volume to your machines and so forth, and add as many blocks as you want to your machines as well. Then you've got Neutron, which, if some of you who may be following OpenStack, this used to be called Quantum, but the hard drive manufacturer didn't like the fact that they called it Quantum, so they changed the name to Neutron. And this basically provides networking as a service, software-defined networking. And there's a number of different projects that feed into this. This enables you to create your own subnet, your own direct tunnel through inside the network using software-defined networking. It ties in with OpenFlow and a few other different projects as well that are all open-sourced in this networking space. Now, there's a few projects here that make up this. So we've got Nova, Swift, Glance, Keystone, Horizon, Neutron, Cinder. I've mentioned all of these already, but these are the things that they were released in their initial forms. The releases down the left-hand side. So the first release was Austin, the second release was Bear, then Essex, the 5th release, and so forth. Obviously, the releases between Bear and Essex, you can see there were no new features added. This was a period where what was done was consolidated, where they basically polished and made sure everything was working properly. It was really, Essex was really the first stable release. And then we have, going forward, a number of other projects which are coming. So we've got Heat, which is an orchestration layer which enables you to basically predefine an entire setup. So you might have 2 load balancers and a number of firewalls and a number of compute storage and compute instances and a number of storage instances, and build it all up with a software-defined network and basically say, that's my configuration, give me one of those, and it'll just build the whole thing, complete with software pre-installed. So if you wanted to run up a PostgreSQL server, or you wanted to run up Magento or whatever, you can just basically fire up the instance with that. Ceilometer is for monitoring and metering. Ironic's an interesting one. This enables you to build a cloud based on bare metal. So you can actually have a cloud of physical machines with no virtualization layer at all, where you can basically use PXE and IPMI to actually fire up physical machines and then physically shut them down again as part of a cloud implementation. Trove provides database as a service. Then there's a few others you can see there. Now, the conceptual architecture consists of a dashboard at the front which connects everything together, and identity services at the back, then you've got the various different components that all talk to each other. Hopefully these slides will be made available to you so you can have a look at this in more detail. So I just want to quickly walk you through an example here. So John here wants to get a new virtual machine running CentOS. So he asks Nova. Nova goes to Keystone and says, "Who are you?" And Keystone, the identity services, reports back that this is John, he's fine. So can I have an IP address, please? So Neutron says, "No worries, I'll give you an IP address." So here's a new IP address. And then Nova says, "Okay, go and start me a new virtual machine," and asks the VM host to deliver a virtual machine for John with that IP address. You want the CentOS image from Glance, and Glance sends back to the VM host a new CentOS image, and then the VM is thing, and then Nova tells John, "There you go for your life." And that, in essence, is the way all the different components all plug together. So I now want to talk about something else for 10 minutes or 15 minutes or something, and then we'll have some questions and stuff. Big data. I want to talk about big data in the open source context because I think with cloud, there's just so much happening out there in the big data space that I really wanted to just, given that I had an hour, I wanted to really share with you some stuff that's happening and why this is such an important time in history. So just some interesting little factoids first. 1956, the first hard drive was released. It was by IBM. It's called the Ramac 305. It stored a whopping 5 megabytes. That's megabytes, not gigabytes or terabytes or anything, 5 megabytes. It was the size of 2 refrigerators and cost at the time $50,000 US. Today, in terms of inflation, I did the calculations, and that's about $435,000. Now, if you take a 4 terabyte hard drive, which cost you, what, about 1,000 Hong Kong dollars today or something like that, you would need 350 billion US dollars, and it would take up an area of 1,600 square kilometres, and that's bigger than Hong Kong. It's pretty amazing, isn't it? And here's another one. About roughly 1981 from my memory, I reckon. This was an ad in a magazine. $3,398 would get you a 10 megabyte hard drive, and in the fine print in here, you've got a 5 megabyte version for $28.98. That's US dollars. So in today's terms, that's about 11K for a 10 meg drive. Would cost you about $4.4 billion for a 4 terabyte drive using that technology. And today's would be a lot more expensive. So just to put this in context, my presentation today using that original drive, this one here, would cost about $800,000 to store. It'd want to be a bloody good presentation, wouldn't it? Now, the data capture evolution. The data capture evolution I want to talk about here. This is over time, we've had 4 phases of capturing data. The first one was when data was stored in computers by professional engineers who initially wired the machines with the data. And then they got improved with punch cards and then pencil cards and so forth. And then we moved into a second generation where we started to have kiosk specialists. This was not professional engineers, but people who were secretarial staff, but trained to enter the data for us. So we would ring up somebody and say, "Hi, I need to book a room in a hospital, or I need to book a flight, or I need to get my phone number changed, or please, I want to pay my bill," or something. And someone would sit there and key the data for us. Today, with the Web 2.0, we have the interactive ability to enter the data ourselves. Now, this was the first generation where the data truly exploded, where the data just basically took off like never before. But then we've had now a 4th generation of data, which is the Internet of Things. Machine-to-machine communications, sensors capturing an enormous amount of data. Now, you're all familiar with Moore's Law, I presume, yeah? Everybody familiar with Moore's Law? Moore's Law is basically, Gordon Moore at Intel said back in 1965 that looking at the data from 1958, we look like doubling our transistor density and therefore our computer capacity and speed roughly every 12 to 18 months. And he said, I reckon that's going to hold true for about another 10 years. And he was wrong in one way. It's held for a lot longer than that. It's been uncannily accurate. And just when we started to think it was slowing down, the 22 nanometer dies have just been updated to be 14 nanometers, and we're going on another generation as well. So the key point here is that Moore's law is doubling every 12 to 18 months, but the data is growing at a much, much faster rate. And the implications are that we can no longer use traditional methods to process the data because it's just too much data. So the processors choke on the data, so we have to come up with new ways of doing that. Our data consumption is growing to the point where we now have, what is it? I'm pointing at my screen so you can all see that. It's stupid. About 5 zettabytes. So for those of you who aren't sure what a zettabyte is, 1,000 gigs a terabyte, 1,000 terabytes is a petabyte, 1,000 petabytes is an exabyte, 1,000 exabytes is a zettabyte, and 1,000 zettabytes is a yottabyte. The amount of data, I've seen this graph over the years about 3 times, and every time it's got the same shape. But the data numbers just change on the side. That's the only thing that changes with the graph as we keep on adding more and more data. So we've got a perfect storm. We've got cheap, high-capacity storage. Data we can now afford to store presentations like this. We can now afford to store all sorts of information. We've got unprecedented data capture. We've got new processing techniques, and I'm going to talk a little bit about that in a minute. We've got a strong marketing appetite for data. And we have Metcalfe's law, which is that the power of any network is equivalent to the square of the number of nodes in that network. A good practical example is if I have one phone, it's about as good as this eraser here. It's useless, except well, it can't even erase, so it's useless. 2 phones is kind of useful. 50,000 phones is very useful. So the idea of this applies to big data in very interesting ways. As we've got more data, more people connected, we can start to analyze the relationships, the interrelationships in very interesting ways. So these new processing methodologies, massive parallelization, the idea of instead of scaling up, we can scale out to many, many machines. Scaling up means bigger machines. Scaling out means many machines without having to scale up, because we simply cannot scale up far enough to cope with the amount of data we want to throw at these machines now. Pets versus cattle, one of my favorite analogies. In the old days, we had dedicated servers. They were named, they were stroked very, very nicely and very carefully. We looked after them very well because when they got sick, we had to work very intensively to make sure they got better because really bad things would happen if we didn't look after them. Today we have cattle. We have cloud computers and so forth that we fire up, we consume, we don't name them, we just number them. And then if they get sick, we shoot them and we get another one. Okay? So the ability also to divide and conquer our workloads. And we'll talk a little bit about Hadoop in a minute. So we've got also the ability to handle semi-structured data. This is really important when you're talking about big data, particularly historic data. Structured data, your relational databases, where you've got very defined schema, very defined structure of the data. Semi-structured data is where that structure can be relaxed. For example, if I have one client who's visited the moon, I don't have to go and create a whole column in my table somewhere that says date moon visited, just for the one person, right? I can add that data in and just store it as semi-structured data. If I've got someone with 6 favourite colours instead of 1, I can add that 6 favourite colours into the database instead of the 1. So just very quickly, I mean, NoSQL has been something that, actually, the term NoSQL, which is really meant to say not only SQL, that's what it means, was actually a term coined by someone from Rackspace originally. But it's a bit of a misnomer because it shouldn't mean NoSQL, it should mean not only SQL. But this is one area of technology that open source has really embraced. And most of the tools that are out there for this are open source tools. So there's 4 really different types of products that make up the NoSQL world. The first of them is key value pairs, which is basically about having some kind of unique identifier, whether it be a GUID or a UUID, or whether it be a social security number or Hong Kong ID or something like that, or something, or a cookie token or something that's unique. But then it has with it associated some block of data that can be accessed only by the key. It's designed to be, these databases or these storage repositories are designed to be extremely fast. But you can't access the data except via the key. And Redis is one example of this. Interestingly, Rackspace acquired a company called Exceptional, which has a product called Redis to Go, which is a Redis as a service. So it's basically designed to just be consumed without you having to worry about that. But there are others here as well. Memcache is a very commonly known one. Columnar databases such as Cassandra, HBase, and Hypertable. These are tools where instead of having the data stored in rows, the data is stored in columns, which enables you to more easily add multiples of addresses or something like that instead of one for one record if it needs it. Designed to handle data that's more fluid in its structure from a traditional database. But some of the trade-offs for these type of databases is that if the object becomes too big, the database starts to suffer quite quickly. So document databases, MongoDB, CouchDB, and so forth. These are databases that are similar to the key value pairs, except your identifier, you then have some kind of block of data, usually something like a JSON or an XML document or something like that. You decide how you're going to aggregate the data. But unlike the key value ones, these ones you can actually also access the data by virtue of what's inside the document. So you can have an XML or a JSON file with an invoice and an invoice number or an invoice date, and say, give me all of the invoices that have, that were issued on this date or something like that from the database. Now, Rackspace has a company called, acquired a company called Object Rocket, which has a MongoDB and has made an investment in CloudAmp, which has CouchDB. These tools are delivered as a service, and my understanding is that the Object Rocket, which is the MongoDB as a service, is something like 3 times faster than any other MongoDB implementation. The hardware's all been designed very exotically with Fusion IO drives and the best possible hardware you can have for this implementation. And it's been designed to set up very, very close to data centers and so forth, so it works extremely quickly. Graph's a really interesting one. Graph, Neo4j and so forth. These tools don't think pie charts and bar charts when you're thinking graphs. These are designed to find social graphs and their interrelationships between various nodes in a graph. And you can ask interesting questions. At the most basic form, you can do things like people who liked this product also liked these products. But you can get very, very complex with the relationships in this. So you can say things like, for example, Mary's friends who have visited places that Mary have not visited like reading these kind of materials. Tell me about all the people who are not Mary's friends, who are friends of Mary's friends, who have visited the same places, but like the same food as Mary's friends, right? So you can have that kind of very, very complex relationship. Quick comparison between SQL and NoSQL. It's very important that people don't think that NoSQL is a replacement for SQL. SQL is designed typically to scale up bigger machines. NoSQL is designed really to scale out multiple machines with shards, designed to break down your workloads. SQL handles atomic transactions. So, for example, when you go and take money out of the bank, 2 things must happen. 1, you get the cash, and 2, your bank account gets reduced. If either of those things don't happen, somebody's going to be unhappy. And when the police get you, both of you will be unhappy. But that kind of transactional support is really important. You need a SQL database. SQL is also more designed around structured data. NoSQL can handle semi-structured data, which means it can handle very, very large workloads without having to have many, many joins. And finally, Hadoop. Hadoop is basically designed to enable you to break down workloads into smaller chunks, both in terms of breaking your data down into like different postal codes or countries or surnames and so forth, but also in terms of steps, step A, step B, step C, and enables you to process incredibly complex, incredibly vast workloads by this divide and conquer method, where you can basically say, I need to do this big task, I'm going to break it down into chunks. So it involves two things: mapping the data into subsections, and then reducing the results back together to form an aggregate. And just a quick illustration here of Hadoop. This is my final slide. If I have a deck of cards and somebody says to me, can you give me the Jack of Diamonds? I've got to go through the deck and find the Jack of Diamonds. But with Hadoop, it's kind of like being able to give everybody in this room one card each and saying, where's the Jack of Diamonds? And assuming someone isn't being a mongrel, the Jack of Diamonds will come to the surface. Okay? So that's the idea of Hadoop. So in summary, cloud computing has changed our lives, and I believe that we've only just begun to explore what it can do for us. But I also believe that open sourcing cloud computing is a really important concept, because we're not going to see the full benefits of cloud when the underlying tools belong to one or two different companies. The fact that Rackspace has open sourced its technology and made it available to many other companies means it's better for everybody, because now you can go and consume cloud from a range of different companies, and you can take all of that benefit and build something that prevents you from being locked into one customer. If you don't like the service that one company's giving you, you can go to another one. And that's all what it's about in terms of this idea of abstracting your business from the IT needs. Last thing you need to think about is, am I locked in? Have I got the right methodology? Shouldn't have to worry about any of that. With an open source platform for your cloud infrastructure, those questions become very, very much a secondary issue, because you can change them much more easily. Thank you. So we've got some time for some questions. Does anybody want to ask me anything? Yeah.
You mentioned earlier that one of the motivations of starting OpenStack is to prevent fragmentation of cloud computing APIs. I think we've largely succeeded in that goal. But still, there's one certain online bookstore that has their own cloud computing service.
Amazon, yep.
Amazon, with their own APIs. Having an API compatibility with them a goal for OpenStack?
Amazon have great products. I've used them. I like them a lot. They're good products. The trouble is they are proprietary. Now, the APIs are, in many cases, are compatible. In some cases, they're not. Now, there's a very big debate in the community. There's a guy called Ryan Bates, who's the CEO at Cloud Scaling, who has basically come out very strongly saying that OpenStack must be fully Amazon compliant. I think there's some danger in that. And it's not that there's anything wrong with being Amazon compliant. The danger isn't that. The danger is that if Amazon starts to dictate all the APIs, then we have a problem. I think what you're finding, though, is very much the opposite is likely to happen. That Amazon will have to be OpenStack compliant if they want to succeed. Now, we're probably 3 or 4 years away from that tipping point yet, I feel. But looking at the acceleration of this, I just can't help but think that that's what's going to happen. I don't want to in any way diminish what Amazon have done. Amazon have done an amazing job of opening infrastructure as a service to the world. I've used their products extensively, and they are great products. But when I listen to them talk these days, what I hear is a lot of, look at my muscles. Look how good we are at what we do. And that's true, they are. But when a company starts to focus on that side of it, then they become, they start to believe it to a point where they get themselves into a bit of trouble. And I worry for them in that sense. And I think there's a lot of hunger in the open source community and a lot of passion in the open source community. And I think that with the growth of this, one of the open source platforms is going to succeed. So then you start asking the question, the corollary question of what about Eucalyptus, and what about CloudStack, and what about OpenNebula and so forth. It looks very much at this stage like the race is over. OpenStack has absolutely, if you look at the statistics, it's just, there's no competition anymore. It's like this is the de facto standard public cloud platform now. So have I answered your question?
So you believe simply by having a bigger momentum than Amazon, OpenStack is no longer need to be like compatible with
Yeah, I think
AWS.
right now there are a number of companies like Service Mesh, RightScale and so forth who provide an abstraction layer across that will enable you to talk across them whether they're compatible or not. And I think at this stage it is important that they are compatible. But what I'm trying to get across here is that compatibility means somebody's got to be the leader, and at this stage Amazon doesn't appear to be interested in being cooperative. That's my reading of it. Now, if they're not going to be cooperative, then there's two choices. One, the OpenStack community has to follow Amazon, which is a silly thing because Amazon are going to do everything they possibly can to prevent that. Or two, that OpenStack goes alone and tries to do things that are sensible, that are compatible, but don't necessarily mean they're only compatible. And then Amazon get themselves in a situation where they are forced to be on the back foot. I think that's likely to be what's going to happen. No worries. Any other questions?
How many nodes you have in the world, and are there any in Hong Kong?
How many nodes?
The storage locations.
Oh, how many storage locations? Rackspace, you mean? Okay, so Rackspace has locations, have 4 locations, we have 10 data centers altogether, 10 around the world, and they are in America, London, Hong Kong, Sydney. And yes, so.
How can a company like Rackspace continue to keep a competitive advantage and moat around the company when you're basically, looks like you're commoditizing everything you possibly can without your business model?
Yes, let me tell you, there was a very, very interesting email that went around the company when IBM announced that they were going to go all in on OpenStack. Because all of a sudden, Rackspace has 5,500 employees, okay? IBM have 450,000, okay? So the email basically said, this is what we wanted to remember, everybody, because the whole idea is we want to get these big people in because that validates the platform. That's the other thing I wanted to say about Amazon. What they have done very well is they have validated cloud for everybody, right? So getting people like HP, IBM and so forth to the table is fantastic. What Rackspace is going to do to compete is this fanatical support. So increasingly, there is a race to the bottom on the infrastructure as a service, right? The basic building blocks are becoming increasingly commoditized. It's going to be, because of OpenStack, it's going to be easy for people to build their own clouds with or without Rackspace or other companies like us. And consuming a public cloud service from Rackspace or from other companies is a choice, but you could also do it privately because the choice is now yours, right? So that means that that side of it is increasingly commoditized. It's where the additional services and support come in that's where companies like Rackspace are going to make money. Now, Rackspace has a facility called Rack Connect, which is part of our secret sauce. And Rack Connect is a brilliant piece of technology that enables companies to connect dedicated hardware, like traditional computing that is hosted by us, with a public cloud offering. So if you've got a dedicated baseline that you commit to, like your regular drive, right? And then you, for example, your product gets to go on Oprah Winfrey or something like that, and all of a sudden, every man and his dog wants to buy your product for 2 weeks, then you can just fire up thousands of servers for those 2 weeks and then shut them down again, all bursting from the dedicated traditional world into the public world because of this RAC Connect. You can also use this RAC Connect to connect private cloud with public cloud and on-premise with off-premise and so forth as well. So that's where the battle will be won in these kind of things, and also the fanatical support. Just in terms of fanatical support, one quick example, one company I read about recently where it was a fairly small company, about 50 or 80 people, and their IT manager deleted all of the email accounts. And then he tried to use the built-in recovery tools, and it was too big a job for the tools, and the computer software just kept crashing. And he went to his boss and he said, what am I going to do? And so he contacted Rackspace. Rackspace, because he was hosting with Rackspace, Rackspace said, yeah, okay, that was pretty silly, wasn't it? And then they got to work, and they had somebody working round the clock for 72 hours, day and night, round the clock, not one person, but every change of shift, they contacted them and said where they're up to, and they just kept on sitting there working, and then somebody wrote a script to automate this, and they just kept working, and they got a little bit, until eventually they broke through and were able to give him back all of his data. And that's the kind of thing that wins you business in the end. Rackspace lives and dies on what we call Net Promoter Score. Net Promoter Score is how likely would you be to recommend our products to your friends or colleagues. A 9 or a 10 is positive. An 8 or a 7 is passive. A 6 to 0 is negative. Right? We're very hard. And so we take the positives, subtract the negatives, and we then watch that score all the time. So that's what we live and die by. Even in our internal training, how likely would you be to recommend this training to your friends? And we have internal, trophies that we give out to the person who gets the highest NPS score in the training sort of thing. Let me tell you a funny story very quickly about my personal experience. We take security very, very seriously. This is off topic, but I'm just going to share this with you. Now, I hadn't been at the company for very long, and I received an email just after an employee survey had taken place. And the email said, it was from hr.feedback@rackspace.com. Here are the results of the latest employee survey. Click here and enter your password to get the latest results. Except this wasn't the employee survey. This was our internal security team testing me, a new senior person, to see whether or not I actually understood about phishing scams. So I fell for it. So I got this big email with great big red letters saying, you were caught, and so did my boss. Now, I was on probation at the time, and I was pretty worried, I must say. But then I told the local IT manager in Australia about this, and he said to me the following. He said, you're going to have to wear the cow suit for a day. Now, I thought he was joking. But 5 minutes later, a costume comes out with the full horns and tail, the whole bit, right down to my toes, my arms and everything, and I was not required, but I was expected to wear this cow suit for a whole day. So there's actually on Twitter, there's a photograph of me giving a presentation on Amazon, actually, on wearing this very uncomfortable costume. But I thought, if I don't do it, I'm going to be in more trouble than if I do. So anyway, any other questions? No? All right, well, thank you very much for your attention. I hope you found it useful. This was for me, was it? Thank you.
London Talk will be starting soon, and after London Talk, we will have our coding sessions, which some of our organizers will speak something, and also we invited one VIP guest to come into the conference, and he is still on the road. So we hope that you will stay until the end of closing sessions, and we would like to invite yours to join the networking hour starting from 7 p.m. At another building.你抄出嚟先，有冇手指抄出嚟？我有佢你試咗啲先。